Greetings, I'm S. Mason Dambrot. The title of my presentation, Theoretical and Hypothetical Pathways to Real-Time Neuromorphic AGI and Post-AGI Ecosystems, is also the title of my corresponding paper. The subtitle, Negentropy and Imagination in Artificial General Intelligence, is added material, and it is material that is rarely covered in the research. The history of human intelligence is based largely on 2 points in history where there were mutations in our neurobiology. 1.5 to 2 million years ago was the first of these in one of our ancestral species. The mutation in question caused a bifurcation in the replication of a genetic sequence that resulted in a relatively rapid growth in the volume of neuronal cells that eventually was inherited by Neanderthals. They had a great deal of intelligence beyond their previous species, but they were far from where we are now. Now, at 500,000 years ago, roughly, there were a sequence in close timing of some mutations, genetic mutations, that led to a great many more connections between neurons. And that's one of the strengths that give us our intelligence. It also caused the reshaping of our skull the way it is now, and that allowed the frontal cortex, the forehead area essentially, that is responsible for our ability to, for example, look into the future and hold simultaneously in our awareness more than one envisioned futures, simultaneously. And in addition to that, there are 2 small areas in the frontal cortex that is unique to Homo sapiens. And that goes a long way to giving us a more robust, unique value in the ability of looking into potential futures and looking at ways of addressing or of avoiding those particular scenarios. One of the primary results of our cortical evolution is our ability to make tools. We are the, by far, leading tool-making species on the planet, and this is obvious, of course. But we are not alone in making tools of various types. This one is interesting. What you're seeing now are 3 different types of nests made by different bird species. The one that's most remarkable is the one on the right. That is constructed by the male bowerbird, and the organization of same-colored findings from the forest, the actual structure of the complex nest itself. This is done by the species in that the male has this technique for attracting the female rather than having complex color feathers that other species use when the male wants to attract a female. This, on the other hand, is our version of construction of living environments, and it's very clear that however complex other species can make their tools, the gap is tremendous and is growing. Human cognition is far more complex than we experience because most of what's going on we are not aware of. We're aware of what we're thinking or feeling at any given time, but this is a small subset of the other functions that are continually in operation that affect what we call cognition, which is in many ways an end product of the interaction of these and other functions. In particular, there is one issue that leads to contradiction when we're trying to analyze a human condition. If you look at the lower left, affect or emotion, biases, and beliefs. Many decisions are made based on these, most of the time without being aware that the decision was made. We tend to believe that our decisions are made rationally, using reason. But studies have been shown that when a decision is made using what is thought to be reason, using fMRI, it has been shown, again, that the decision had already been made very, very briefly into the past by different brain structures, and we are completely unaware of that decision already being made. Focusing on four of the components of the prior slide, that is affect, beliefs, and biases, as well as reason, the development of artificial general intelligence, in order to be not a simulation of human intelligence, but an actual human analogous intelligence, rationality and reasoning are not enough. That AGI must have a core of emotional cognition. There must be an awareness of biases that develop, and there must be an awareness of beliefs that are not factual, but are nevertheless very influential on thought and decision making. Another perspective on human and AGI intelligence is that of consciousness. When looking at internal and external behavior in humans, we're focusing in this slide on intention. The point is that the intention of a thought, of an articulation, or a physical action can have two sources or two contexts. It can be implicit, that is to say, one would not be aware of what is driving that thought, articulation, or behavior, or it's explicit. There is a factor of self-aware understanding of what is driving that particular intentional action. In this case, in an AGI, it may be possible for the AGI to become aware of what is implicit for humans. That would be one significant difference that would allow AGI to have a higher degree of self-awareness than human beings can achieve. And that would be a very important focal point when AGIs are developing into their full potential. Negentropy is, as may be inferred, the inverse of entropy, where entropy is the process and merger of increasing disorder. Negentropy is the opposite. That is, over time, the process and measure of increasing order. What's important is that life itself is inherently negentropic. Life creates order and complexity increasingly over time. And it's very simple in its structure, in that it's simply a matter of time differential. The important part in relationship to human beings and AGI is that AGI, if truly human analogous, would be able to create order over time, as do human cognition does. When applying negentropy to the ideation and realization of tools, whether objects or processes, the key point is that imagination is the negentropic function that generates the ability to go from an idea to a physical reality. When it comes to negentropy in the imagination of an AGI, this is another factor that will be necessary for an AGI to be considered to be human analogous, because without that, the cognition parameters of an AGI would be quite different from that of human beings. Another important trend in the development and emergence of science and technology are the transition from multidiscipline through interdiscipline to transdiscipline structures and relationships between different bodies of science and technology. In multidisciplinarity, each body of knowledge are separate. They may interact, but they are largely separate. The next step was interdisciplinarity, in which they are linked. They are separate, but they are linked. The trend now that is accelerating is transdisciplinary, and that is the fusion of different bodies of science and technology in such a way that they create a new unitary entity that stands alone, incorporating the components and knowledge of the previously separate and discrete bodies of knowledge and technologies. One future scenario is quantum AGI, in which artificial general intelligence, counterfactual quantum entanglement, and neuromorphic quantum computing, all in different stages of development, will merge, creating a very high-functioning body of knowledge in both science and technology that will allow artificial general intelligence to go significantly beyond what the expectations are for AGI over the next several decades. Further down the road, one can expect a variety of transhumanism and post-humanism technologies in a number of steps over time. One would be the merger of neurobiology, somatic physiology, and biomorphic genetically expressed nanotechnologies. The next being humans transmuting into a subspecies based on an ever-increasing integration of nanotechnologies into the biology of human beings. Next again, the accelerated evolution again transforms Homo sapiens into a life form recognized as a new species, and finally, an ever-increasing range of genetically designed post-human life forms that would be ever more distant from the original Homo sapiens. Another future scenario may well be artificial superintelligence variants, and two in particular. The first being genetic computing artificial superintelligence that, among other technologies, will utilize CRISPR-Cas9, or more likely, more advanced genetic editing technologies to achieve modifications that are not available today. A second variant would be quantum computing artificial superintelligence, which would engage the benefit and advantages of quantum mechanics, including entangled-based communications, superposition-based parallel processing, supraluminal instantaneous processing speed, and an infinite number of threads. A far future scenario, which I've christened transentity universal intelligence, would encompass two primary components. The first being a real-time bidirectional multi-stream neural-to-speech, speech-to-neural signal transcoder. The second being a real-time bidirectional multi-node interlingua interspecies translator. This system would allow immediate and distance agnostic conversations between two intelligent species without having to learn the language of the other. The emergent innovations I've discussed are in good company. Specifically, two quotes, one from Albert Einstein: "Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world, stimulating progress, giving birth to evolution." The second is, in my view, rather poetic. "Any sufficiently advanced technology is indistinguishable from magic." And that came to us from Arthur C. Clarke. Returning to the present, Uplift is a currently high-functioning AGI-based mediated artificial superintelligence developed at AGI Laboratory. Uplift has a self-motivating, emotion-based cognitive architecture, is, again, operational as we speak at a superhuman level of cognition, and is able to converse via print alone at this time at a human level that is often difficult or sometimes impossible to discern whether or not it is a human being or Uplift. And to that, I thank you and hope to hear from you with any questions or anything that interests you.